Good morning, dear students. Today we will learn more about electronic configuration. So let's try to write the electronic configuration of fluorine. The atomic number of fluorine is 9. That means there are 9 protons in the nucleus and 9 electrons are there in the atom. So how are the 9 electrons distributed in the various orbitals or various shells or various subshells? So that is what electronic configuration is. So as per the Pauli's exclusion principle and the Hund's rule of maximum multiplicity and our Bohr principle regarding the various regarding how electrons are filled up in orbitals according to their increasing energy is this. It will be 1s2, 2s2, 2p5. 2 electrons in the 1s subshell. 1s shell or 1s subshell because in the first shell there is only one subshell, then 2s subshell and 2p subshell. Only 2 electrons are possible in s subshell, so there will be 2, 2, 4, and the remaining 5 electrons will be 2 plus 2 is 4, 4 plus 5 is 9, will be in the 2p subshells. So this is the electronic configuration of fluorine: 1s2, 2s2, 2p5. How this is represented in the orbital picture? It's like this. So 1s orbital, 2s orbital. There are 2p orbitals. There are 3 2p orbitals: 2px, 2py, and 2pz. How is this fill up? According to Hund's rule of maximum multiplicity, first the orbitals having the same energy or degenerate orbitals should be filled first. Should be singly filled, because we know that in orbital only 2 electrons can occupy same orbital. So it will be singly filled, then pairing will take place. So 2 orbitals are paired, and in the last orbital, 2p orbital, there's only one single electron. So this is the orbital picture. It becomes clearer in orbital picture how the electrons are distributed in the 2p subshells. Now let's come to neon with having atomic number 10, as just having one electron more than this. So how the one electron will fill up? It will obviously fill up here, right? So this is the electronic configuration of neon. Neon, which is written as 1s2, 2s2, and 2p6. So what comes next? Next atom having one more electron than neon is sodium, Na, atomic number 11. So the next electron will go to the 3s subshell. So it will be 1s2, 2s2, 2p6 is up to is same as neon, and then comes 3s1. So it will go from sodium, then magnesium. It will go on like that. Sodium, magnesium, aluminium. So up to atomic number 18, argon. What will happen next at 3s, and after 3s comes the 3p orbitals. It will fill up. There will be 6. The 3p subshell can accommodate 6 electrons. So in argon, all the electrons at 3p will be filled up. It's 3s2, 3p6. So what comes next is, it should be sodium, argon, neon. So how can we write the electronic configuration of sodium? So there is one more way of writing the electronic configuration of sodium. How will we write? See, the electronic configuration of neon is 1s2, 2s2, 2p6, in which the second subshell or the second shell is completely filled up. It's filled up. Now comes the third shell. First shell, second shell. 2p comprises second shell. It's completely filled up. So so neon is quite stable. So we can write the electronic configuration of sodium as neon plus 1 electron. So instead of writing from here to here, we can write this from here to here. We can write this as the electronic configuration of neon. So we write neon like we write that symbol of neon in third bracket. Then we write 3s1. So this is another way of writing the electronic configuration of sodium. Instead of writing like this, up to from here to here, we will condense it, and we'll that this is from here to here is a electronic configuration of neon. Then the third shell is added, 3s1. So two more. I want to introduce two more terms over here. The first is the valence electrons and the core electrons. What is valence? What are core electrons? Core electrons are electrons that are present in the inner shells, the inner shells of the inner shells of the atom. See, this the first shell and the second shell. These are inner shell. So these are regarded as core electrons, and those electrons which are present in the shells or in the shells having the highest number of principal quantum number, that is called valence electron. So here these two subshells having principal quantum number 1 and 2. The highest the subshell having the highest principal quantum number is this 3, and there is one electron. So these are known as valence electron. The electrons that are present in the highest shells having the highest principal quantum number. Okay, let's see here what will be the valence electron in fluorine. In case of fluorine, this 1s2 will be regarded as the core electrons because they are present inside. And and these 5 plus 2, 7 electrons, they are present in the principal quantum number having the highest. Here 2 will be the highest principal quantum number. So in second subshell there are 7 electrons. So these 7 electrons are valence electrons. I hope you understood.